we are trying to find the direction of vectors, and this is a lot like polar form. Polar form. All right, so we're just kind of making that comparison. The direction is going to give us like an angle, and then we'll put that together with the magnitude later to re-represent this in kind of a trigonometry sort of way. So the first thing you always have to do is you need to graph it so we can see where we're at and what quadrant we're in. So, boy, that's an ugly y-axis. Let me go ahead and draw this again. All right, so let's try a little bit better. All right, so this is our change in x right here. This is our change in y right here. So luckily I and J have that same alphabetical order as the x and y, and then this kind of represents it as a unit style. But let's go ahead and get into it. So -7 for the x, so -7, 1, 2, 3, 4, 5, 6, 7 in the negative direction for our x. And then our y is -10, 1, 2, 3, 4, 5, 6, 8, 9, 10, down here, -10. All right, so then our terminal point would be right here. And then just to make our lives easier, we start at the origin. So there's the vector that we're trying to look at. And what that means is when I look at this, I would start on the 0. Remember, this is a 0, and I already got my -7 and my -10, and that's also equal to 360 degrees. All right, so I'd start here, and I go around, and then there's the angle that I want. So this is the theta that I want. I'm going to go ahead and switch out of that yellow. That's really hard to see. So the theta that I want here, all right, is all the way around. Okay, so I'm trying to find out what that degree is. And what I'll do here, and whenever you have this type of situation, what you want to do is you want to make yourself a right triangle with the x-axis. So here's my vector. Here's the x-axis that corresponds to it with that side. And then I would just make that right triangle right there. So now that's a right triangle. And then we analyze what this angle is, and then we can kind of add 180 degrees to it to get out what the theta is that we want. Okay, so let's just label some things right here. So this side right here is a -7. This side right here is a -10. This is our adjacent side to the angle, ADJ. This is our opposite side to the angle. Okay, what angle am I talking about? I'm going to go ahead and call this angle phi, so I don't confuse it with my theta. Okay, so I know it's a little bit hard to see right there, so I'll go ahead and draw another. So there's my phi that I'm looking for, and this is -7 on this side and -10 on this side. Okay, so how would we do that? We would look at the trig function to find out what this theta is, which is tangent. Tangent, and this was our adjacent, this is our opposite side, to phi. All right, so tangent of phi is going to be equal to, opposite over adjacent is tangent, opposite over adjacent. And that would be equal to our opposite side is -10. Our adjacent side is -7. All right, so we'll do arctan to both sides. So that gets rid of the tangent, and we have phi equals, and then what we do to one side, we do the other. So we have arctan on this side, or tan inverse, of 10 over 7. I'm going to go ahead and just get rid of those negatives, negative and a negative, make a positive. All right, so I'll go ahead. We need to type this into the calculator, and then out will pop what this angle is. So we got a calculator option. I'll use it. So tan inverse of 10 divided by 7 in parentheses equals 55. 55. All right. So let's see, what does that mean? So I got phi is equal to 55.007 ... All right, and that's a degree. We are in degrees here. I forgot to make sure. I'm just checking right now. We are in degree mode, so everything is okay. If we were radians, I'd have to do this work over. All right, so does that make sense? We got a 55 degree way over here. Well, what that means is 55 degrees is right there, right? 55 degrees. So what we did is we found, let me switch colors here. We found like an extension of what that angle is that we're looking for, right? So 55, it's going to have a matching on this other side right here. So the 55 for my phi, I'm going to add the 180 degrees to it. Okay, and I kind of mentioned that in the beginning. So the 180 degrees, I'm going to add to the 55, and then that's going to throw it down right here, which is what I want finally. So it's going to give me what I want right here. All right, so the phi plus 180 degrees, that's going to give us our theta that we want. All right, so I stored this on my calculator and made sure I just didn't delete that. I need that infinite decimal. We only round at the end. So this number plus, so answer plus 1/8. I just got rid of it. So I need to do it again. So tangent, arctan of 10 divided by 7. It really wants me to close that parenthesis. Fine. All right. And then 1, don't hit the log, 8, 0 plus that answer is what I was wanting. All right. So I got 235, 235.00797 ... All right. So does that make sense? It kind of does. So remember, this is 270 degrees right here. So it has to be less than 270 because we're in quadrant 3 here. So it seems okay. Let's just be careful. We want to round to the nearest hundredth. So here's the tenths place. Here's the hundredths place. So I look at this number. It's a 7. That means that theta is approximately equal to 235.01. All right, and it seems like everything links together here. We should be okay. Let's see how we did. 235.01. All right, got it. Okay, so just kind of be careful about your strategies when you do these. The big one is kind of dealing with those triangles, knowing what quadrant you're in. So you have to graph it first so you know what quadrant you're in, and then you just kind of think about the 180 degrees and how it applies to the different situations. You could land in the negative. You could be kind of going this direction. Sometimes that happens, but you'd do exactly the same kind of process, keeping track of what angles you are responsible for.